This time, we're going to solve for acceleration in the equation df equals di plus vit plus 1/2 at squared. This one's going to be a little bit complicated, but not too bad. The first thing I want to do is get rid of df and di and just use one term instead of two. If I subtract di from both sides, I get df minus di equals initial velocity times time plus 1/2 at squared. The good thing about this is that this can be reduced down to delta d, or my change in distance. So now instead of having two things, I've just got one. Equals vit plus 1/2 at squared. The next thing that I'd like to do is bring this term to the other side. Since this term is added to this, I'm going to have to subtract from both sides. So subtract initial velocity times time from both sides. I get my change in distance minus my initial velocity times time equals 1/2 at squared. Now, this 1/2, a little bit ugly. So the way that we can get rid of 1/2 is to multiply both sides through by 2. Now on this side, I get 2 times my change in velocity minus vit. Notice something really important. I've got parentheses here. If you don't put your parentheses there, you'll have to distribute your 2. So it would be 2 delta d minus 2 vit. Now, on the other side of the equation, 2 times 1/2 gives me 1, so I'm left simply with at squared. I'm solving for a, so I want to move my t. This is a multiplication here, a times t. So in order to undo a multiplication, I'm going to divide both sides through by t squared. This canceled, and I get acceleration equals, don't forget your parentheses, two times delta d minus vit inside parentheses divided by t squared. Now, if you're like me, you want to check your work to make sure you didn't make a mistake. If we've done this correctly, the units we're going to get, the units we'll end up with, are going to be meters per second squared, because acceleration is measured in meters per second squared. So let's just check. I'm going to put this into dimensional analysis form, just so I can spread it out and take a better look at my units. Okay, notice that these two equations are equivalent. They're just written a different way. I'm not worried about numbers because all I'm trying to do is check my units. Since I'm not worried about numbers, I'm just going to plug in units to see if I come up with what I need. Now, change in distance is going to be measured in meters per second. Velocity, well, here I am lying to you. Start over. Change in distance is measured in meters. And then velocity, here we go, this one is measured in meters per second. Time is measured in seconds. So on this particular term right here, I'm going to end up with meters minus meters. So my unit for this term is simply meters. Over here, time is in seconds, so if we square it, we get seconds squared. When I bring this one down, now when I multiply my two terms together, the units I end up with are meters over seconds squared. Now I can feel pretty happy and confident that I have solved my equation correctly.